So what is electrostatic potential? Let us understand the story in which there is a Rocky Bhai and there is a Garuda. Who is Rocky Bhai? Yes, the hero from KGF. Here, the Kolar Gold film, that Kolar Gold field will be represented by our electric field. So here, what we have our Rocky Bhai. We have a Rocky Bhai point Q, and he have is called KGF. His KGF will be our electric field, which will be represented by E. Who is Rocky Bhai? Yes, Rocky Bhai is the hero in the movie. Now, in this area, a villain wants to enter. That villain name is Garuda. He will be represented by small charge Q, and his value will be only 1. He will be the unit positive charge. He will be the unit positive charge of 1 coulomb. Now, this Garuda wants to enter into the KGF. Will Rocky Bhai allow him to enter here? No. There will be a certain sort of attraction or repulsion in between Rocky and Garuda. That only we are going to study in this chapter. See, the chapter which we have studied, that is electric charging field, and the sequence which we are going to see in this chapter, the difference is in electric charges in field. First you study about the charges. First you study about the charges. Then you studied the fields of charges. Then you study field of charges, electric field of charges. In this chapter, what we are going to study, you are going to study if a unit positive charge tries to enter into the field, what will happen? What will happen when this unit positive charge will try to enter here? What will happen? There will be a displacement of this charge. If there is a displacement, that means something is applying force on this small charge q. If something is applying force and there is a displacement, that will be known as what? That will be known as work done. Means we have to study about the work done. Yes, we have to study about the work done. Then if there is a work, if there is a force, if there is a displacement, there will be a work done, and that work done will be stored in the form of what? It will be stored in the form of energy. And that energy is known as what? Yes, that energy is known as potential energy. After that, you'll have to store this potential energy. So yes, we have a device, and that device is known as what? That device is known as capacitor. So what's the work of capacitor? Capacitor usually store the energy. So you got the mind map what we are going to study in this chapter. In previous chapter, we studied about the charge. We studied about the electric field. In this chapter, what we are going to study? We are going to study if charge tries to enter the electric field, then what will happen? There will be a displacement. If there is a displacement, 100% there will be a force. If there is a force and displacement, there will be a work done. If there is a work done, there will be the energy. If there is the energy, that energy is known as what? That energy is known as potential energy. And we have to store this potential energy. What will use? We'll use the device which is known as capacitor. Okay. Now let's move further. What do you mean by electric potential? An electric potential is the amount of work needed to move a unit electric charge from a reference point to a specific point in an electric field without producing an acceleration. Now, once again, let's take the example. Let's take the example that this is a charge, a big charge. That charge have electric field. If I want to bring an external charge from infinity inside the field, what I will have to do? I will have to work. So the amount of work, which is done to move a unit positive charge from reference point to specific point is known as what? It is known as electric potential. Once again. Everyone, is screen is visible to everyone? Is the full screen visible to everyone? Yes. Okay. So once again, we'll revise the thing. What is the meaning of electric potential? Yes, it is the amount of work done to bring a unit positive charge from a reference point to specific point is in an electric field is known as is known as electrostatic potential. Now, more about this, we have so many numericals, so many MCQs from, not many numericals, many MCQs are expected from this topic. The before proceeding for the MCQs, we are going to discuss that. You know what is the unit for this electrostatic potential? Yes, what will be the unit? So the unit of electric potential is is yes, it is volt. Is it a scalar quantity or vector quantity? Yes, it is a scalar quantity. What do you mean by scalar quantity? The quantity, yes, the quantity which have only magnitude, no direction, then it is known as what? It is known as scalar quantity. And the third thing, what will be the formula? So the formula for electrostatic potential V is K Q upon R. I hope you know what is K. What is K? K is our constant. The value of K is 1 upon 4 pi epsilon naught. I'll give the direct form. I will give you the direct value. It is 9 into 10 raised to 9. What is Q? Yes, Q is charge. What is Q? Q is your charge. And what is R? R will be distance. Okay, so I hope it is clear what is your electrostatic potential. What is electrostatic potential? Yes, an electric potential is the amount of work done needed to move a unit of electric charge from a reference point to a specific point in an electric field without producing an acceleration. Okay, then what will be the unit for electrostatic potential? Unit will be volt. Will it be a vector quantity or scalar quantity? It will be a scalar quantity. And what will be the formula? Formula will be V is equal to, yes, K Q upon R. This will be the formula. Let's see what's there further. Consider electrostatic field E caused by some charge arrangement. Consider the field E produced by charge placed at the origin. Consider the moving charge Q from point R to point P while resisting the repulsive force exerted by charge Q. If Q and if Q, if this Q and this Q are both positive or both negative, this will occur according to the figure. Let us assume that our Q is greater than 0. That means it is what? It is greater than 0. That means it is what? Yes, it is a positive charge. Now, for a certain sake, hence two observations are possible. First, we suppose that a test charge Q is so small that it does not alter the original configuration, which is Q at the origin. Second, we provide an external force to move the charge Q from R to P, with an extremely slow constant speed, that is just strong enough. I repeat the second one. We provide an external force to move the charge Q from R to P that is just strong enough to oppose the electric force that is pulling in opposite direction. This indicates that the charge Q moves from R to P with an extremely slow, constant speed and without any net force or acceleration. In this case, the work produced by external force equal to the work produced by electric force and is completely stored as the potential energy of charge Q. Now, what about this potential energy? We are going to discuss it about the later when we have this topic. Okay, now we'll move to the next topic. Before that, yes, we have some formulas. We have some numericals. We have some MCQs. Let's see the first MCQ. Electrostatic potential and capacitance, the first one. The first MCQ. Select correct formula for electrostatic potential. What is the correct formula? A. Electrostatic potential is equal to work done into charge. B. Electrostatic potential is equal to work done per unit charge. C. Electrostatic potential is equal to work done plus charge. D. Electrostatic potential is equal to work done minus charge. Let's see who will give the answer. Will give the right answer. Everyone in the Q&A session, what will be the correct formula for this? Yes. Radhika, why A? Electrostatic potential is equal to work done into charge. Why A? Badul, why C? Yes, Manohar, that's the right answer. B. Electrostatic potential is equal to what? It's work done per unit charge. Very good, Manohar. The right answer is electrostatic potential is equal to work done per unit charge. We saw the definition. In the definition, we have that thing that the amount of work done to bring a unit positive charge to the reference to the specific point is known as what? It is known as electrostatic potential. So it will be what? It will be work done per unit charge. Okay, let's move to the second question. Yes. The next one is, assume that by using an external force, charge we move from point R to point P. Which of the following energy transformation would occur if external force was eliminated upon reaching P? Yes, the question is, assume that by using an external force, if we move from point R to point P, which of the following energy transformation would occur if external force was eliminated upon reaching P? What will happen? if we are using external force to bring charge from R to P, which energy transformation will occur? The first one, kinetic energy into potential energy. Second one, potential energy into heat energy. Third one, potential energy into kinetic energy. The last one, gravitational force to potential energy. What will happen? Yes, what will happen, everyone? Please answer. Yes, Shraddha, what's the answer? YA, Sawan, YA. See, first we'll eliminate the wrong answer. See, there is a no role of heat energy. There is a no role of heat energy. There is no role of heat energy. No, neither there is a use of potential. Neither there will be a role of gravitational potential. So we'll cut this two question. Okay. Now, the correct answer can be from A or it can be from C. What can be the right answer? Yes, if we are bringing a charge from R to P, which type of energy transformation will be there? Yes, option C is the right answer. There will be a change of potential energy into kinetic energy. There will be a change of potential energy into kinetic energy. So answer C will be the right answer. Okay, let's move to the next question. Define electrostatic potential. How you will define electrostatic potential? Yes. Anyone in the comment section? What will be the electrostatic potential? It is defined as the, I had already given you the definition, just I'm writing the key points that how you will define the electrostatic potential. It is the amount of, yes, yes, say what it is. It is an amount of work done to bring unit positive charge from a reference point to specific point. Amount of work done to bring unit positive charge from reference point to specific point in an electric field. Yes. Without producing what? Without producing acceleration. Okay, clear? Now, the next one. How you will define 1 volt? Yes, how you will define 1 volt? See, previously we saw the definition. We have the formula for electrostatic potential. The formula for electrostatic potential is work done. Yes, work done per unit charge. Right? We have formula. We have formula of electrostatic potential. Electrostatic potential is Work done per unit charge. What about unit? Unit of work done was in joule. Unit of charge was in coulomb. What is joule per coulomb? Joule per coulomb is nothing but your volt. Now we have to define 1 volt. What can be 1 volt? 1 volt will be, yes, it will be 1 joule per 1 coulomb. With this, can you define with the help of this? Yes, this is one volt. Why? Because the formula for electrostatic potential was work done per unit charge. What is work done? Work done is joule. What is charge? Charge is C, coulomb. What is joule per coulomb? Yes, joule per coulomb is nothing but your voltage. So how you will define 1 volt? 1 volt have to be defined by 1 joule per coulomb, per 1 joule upon 1 coulomb. How you will give this mathematical expression a state into statement? How you will convert this mathematical expression into statement? Anyone? Very good, Ganga. Your previous answer was very good. Now, can you please define this? What is 1 volt? How you will define 1 volt? Anyone? Shamta? Shraddha? Akhil? I'll define this thing. What do you mean by what is 1 volt? What is 1 volt? Yes, it is 1 joule per coulomb. It means what is 1 volt? It is 1 joule of work done required to move 1 coulomb charge. That's it. If 1 joule of work is done to move a unit positive charge, if 1 joule of work is done in moving 1 coulomb charge, then we can say, if 1 joule of work is done in moving 1 coulomb charge, then it is what this is our 1 volt. Okay, let's move to the next one. The next topic is potential due to a point charge. Yes. Potential due to a point charge. Our next topic is potential due to a point charge. Now, potential due to a point charge. Let's start with the same example. We have point Q and we have small q. This is our Rocky Bike and this is our Garuda. Okay, and the Rocky Bike. Where is Rocky Bike staying? Rocky Bike staying in KGF. Yes, for that KGF will be our electric field. That will be our electric field. What we are doing, we are applying some external force to bring our Garuda in between the point joining. Let us see. Let us consider this is our point P. This is our point P. The distance between Q and P is this is R. As this Garuda is trying to come inside, there will be a sort of attraction or repulsion. See what we did a work. We have to find, and that work, what is that work? See how to find, before that, how to find the potential. How to find the potential? Anyone? See, let us consider this is our pen, this is our pen, this is our surface. If I am just taking this pen up, what will happen? Yes, this pen will be attracted by a force, gravitational force. Why? Because in this, the energy stored. What is the name of that energy? Yes, that energy is gravitational potential energy. That same, see, whenever we are working against the force, this was a gravitational force. If we are working against the gravitational force, there was a storage of energy, and that storage of energy is known as what? That is known as potential energy. Same will happen here. Same will happen here. Okay, when so that the whenever we are working against the force, there will be a storage of energy, and that energy will be known as what? That energy will be known as potential energy, gravitational potential.